Hello everyone, welcome to our channel. Today we're going to discuss Maxima and Minima. Okay. Calculus is about the relationship between quantities represented by variables stated in an equation. Oftentimes, we need to find a certain value of a variable that will either yield the maximum or minimum values of the dependent variable. For example, the maximum amount of volume of a cylinder with respect to the height and radius of a right circular cone. So to see this, we have the diagram, which is a right circular cone and the cylinder inside. So what will be the arrangement for what would be the value of the radius of the cylinder and the height of the cylinder that would fit the maximum volume, okay, inside the right circular cone. So it's a unique set of values, and there's no other values other than that, okay, and we need to figure it out. So we need to find the maximum value using differential calculus. Okay, so here's our picture. Okay, and we let some variables to stand for what we're looking for. So we let x to be the radius of the cylinder, which is coming from the centermost part towards the edge. Okay, this is also the radius of the cylinder below. Alright, so and we have y for the height of the cylinder, which is coming from here towards the bottom. Okay, and next is the height of the cone, which is from the apex towards the base, and r for the radius of the right circular cone from the centermost part towards the edge. And the volume of the cylinder is given by V is equivalent to pi x to the power of 2 times y, or pi x squared y. Alright, so next is it seems impossible because there are different variables. So we express the volume of the cone and of the cylinder using the same variables. And you'll notice here that there are triangles that are being formed. This is a small triangle, okay, which has a value of base x, okay, which is also the radius of the cylinder, and the big triangle here, which has a radius which has a base r, which is also the radius of the cone. So we will use triangle similarity concepts. In this way we can find y, okay, so which is the height of the cylinder. Here, this part from this point towards the apex is h minus y. Okay, so the ratio between the radius of the cone and of the cylinder is given by x all over r, okay, which is proportional to this side. Okay, let's use this as a relationship. Okay, so h minus y is this part, I've mentioned that, and with respect to the total height, okay, h minus y all over h. So we can find y, which we are trying to figure out, which is the height of the cylinder. Okay, so y is equivalent to h all over r times the quantity of r minus x. So we'll substitute it to the volume formula for the volume, which is pi x squared y, and we'll get volume V is equivalent to pi x squared times the quantity of h all over r times the quantity of r minus x. So next is we distribute the x squared towards r and this one, and we'll get volume V is equivalent to pi times h all over r times times x squared minus x to the power of 3, which is the new formula for the volume of the cylinder inside the right circular cone. Okay, so this is the formula, and then we'll figure out the maximum volume with respect to the radius, okay, which in turn can be related to the height of the cylinder. So that means there's a comparison, so there's a rate of change which is constant, which later on be dv all over dx must be equivalent to 0. So we differentiate with respect to x. Okay, so from this equation we differentiate. We have dv all over dx is equivalent to pi times h all over r times 2x to the 2xr minus 3x to the power of 2. Okay, now let's equate to 0. So we have dv all over dx is equivalent to pi times h all over r. We factor out x times the quantity of 2r minus 3x. Okay, and we will see that 1 root is equivalent to pi times h all over r times x is equal to 0. So this has no value, so the volume is 0 when this is 0, so this has no meaning. So what we can accept is this part, 2r minus 3x is equal to 0, and we'll solve for x, and x is equivalent to 2/3 r, wherein r here is the radius of the right circular cone. So it's always in a ratio and proportion. So at 2/3 r, you can erect the cylinder and figure out its height. So we'll go back to the equation for the height of the cylinder. We'll substitute it to y is equivalent to h all over r times r minus x, and we have the value of x. We'll get h all over r times the quantity of r minus 2/3 r. We'll factor out r, and we'll get r over r is gone. It would be equal to 1, and we have h minus h times 1 minus 2/3, which is 1/3 h. Okay, so we have x for the radius. Now we'll give the maximum value, and its height would be at y is equivalent to 1/3 h. So these are the only two values that will give the maximum volume of a cylinder when inscribed inside a right circular cone. Thank you for watching.